Next one is people standing in a row. Okay, that's one way of looking at it. Or things being stacked, and you're asking for arrangements. Okay, you're not making groups, you're not selecting, and you're figuring out how many ways can you select. This is actually stacking, arranging, order matters. There could be specific positions. I'm going to use the word arrangements. How many ways can you line up? Okay, anything like that is kind of very particular to this category right here. So what I want to talk about here is, so I'm going to keep numbers very small. 4 people standing in a row, so they're lining up. How many ways can you do that? Obviously 4, 3, 2, 1, or 4 pick 4, and that is the equivalent technically of 4 factorial. I'm not going to answer that. That's 24, but it's just so you know how to set it up. What if it says having 2 on either end? So you have a particular case. Let's say you have 2 people in particular. It could be coaches. It could be 2 people that are named. They need to be on either end. So you kind of want to do that first. You've got 2 options to put them in the first place and then 1 in the second. Okay, you're basically saying with that you could have them this way and then flip them the other way. Okay. And then once you've taken these 2 away from your 4, you put in the rest here. So if we had, 5 people, you do 2, 1 on the end, and then you're down to 3, 2, 1 in the middle, right? So that is on either end. Let's say 2 or more are supposed to stay together. If it's 2 together, you kind of take 2 of the slots you've created, right? 4 in total. In this case, you go 2 factorial, make a circle around it. That is your zooming in, your 2 factorial. And you would do this for as many groups as are created. Then you want to zoom out and realize you count this as 1 slot. So this is 1, 2, 3. That's 3 factorial. So the answer to how many ways can these people be arranged if 2 need to be together is 2 factorial, 3 factorial. Always do a zoom out at the end. Okay, always. If it asks like how many ways can they not be together, 2 not together, in this case, you would take 4, why is there 10p4? My bad. That is 4 pick 4. Okay, 4 pick 4, that is like all possible ways of arranging them, minus them being together, and then you have not together. So if it asks you for the probability of these 2 people not being together, okay, you would go, probability would be 2 factorial, 3 factorial over 4 factorial, right? And that would be your probability. So this is just a number of ways that they're not together. This is the number of ways they are together, and so forth. I want to add a layer to this that I haven't, I don't think that came up in class, but here it is. Alternating. So this is new. If you're watching this, good on you. I don't think it's a stretch to do this, okay? But let's say you have 4 dogs and 4 cats. How many ways can they stand or arrange side by side if they are alternating? If they're supposed to be, I'm going to highlight the dogs, right? So let's say you start with dog, cat, dog, cat, dog, cat, dog, cat, right? So you're alternating them. So I first focus on the dog. So there's 4. So 4, 3, 2, 1 in a sense, right? And then I put the cats in between them. They're alternating. So right, 4, 3, 2, 1. So it ends up being 4 factorial times 4 factorial if you think about it. That's 576. But you might think there's only one option. And that's where this a little bit more complicated, because there's another option. Always think about, is there possibly a way that this could change? And here it is. What if you start with the cats, right? So cat, 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 right? So that's one option to start with dogs, and then next to start with the, sorry, one option is to start with dogs, the other one is to start with cats. And if you think about it, it's still 4 factorial times 4 factorial. So in this case, to get the full marks, you would have to add these two up and say there's this many ways. Because think about it, starting with cats versus dogs is a completely different setup. It is a different picture. Okay, so that is what I wanted to add for pictures or arrangements where order matters. Okay.